Oh, we got crickets. Is my mic still working? Nobody wants to try it, huh? Wow, it's a good thing I chose this one as bell work. Any ideas? Maybe talk it out with me. Ideas. How we can
Okay,
start.
so I know -6 is the first number, and then 0.05 is the last one. Gotta be 5 values in between there. After that, I got lost.
Okay, that is a great start. So let's go ahead and let me get my pen out. So let's go ahead and write. We got -6, and then we got some number, another number, another number. You said 5, right?
Yes.
And then we have 0.05.
And Dynica wants to do it.
All right, Danica, you want to explain first how you solved it? Hear what your first step is before you start writing. Mike, if you could, please, just because people who are watching this recording later can't see the chat log.
Can you guys hear me?
Sure can.
Okay. So since there's 5 values and the first one is -6, as Antonio said, you would put that for the A1. And then since it said that there's 5 values, I think I already said that, it would be A5 equals 0.05. And then I used the SN equals N over 2. A1 plus AN. And I just plugged in, since N is 5, into all the N values. And then I did -6 plus 0.05. And I got -5.95. And then I just did 5 over 2 times -5.95. And I got 14.875.
That would be excellent if you were finding the sum. So remember, you're trying to find those 5 values, and you gave me one value. So I put all the formulas we learned yesterday on the board here because I wanted you to. I don't want to trick you, but I wanted you to choose correctly. And the ones with the S sub n, those are your summation formulas. Now, if this problem gave this and it says what is the sum of the first 6 values, you would be correct. But I want you to find those missing values. But you are on the right track with kind of how you said use 0.05 as your A sub 5. So that is a good start. But you don't want to use your summation formulas. So Danica, you want to try again?
Emily says she knows part of it.
Emily, go for it. Try to explain.
So I know that you need to find the common difference first. So I'd used the AN equals A1 plus N minus 1D. And I plugged in the 7th value. So I did 0.05 equals -6 plus 7 minus 1D. And calculating that out, you would have 0.05 plus 6 would be 6.05. And then divide that by 6. So 6.
All right, Emily, go for it. Go for it. Yes, that is correct.
Yay!
So go ahead and write it. If you want to, you can write it or I can write it. It doesn't matter.
Yeah, you read it because I can't write.
Yeah, we don't want to see your All right. So we're using that first formula, the A sub n equals that stuff. So a sub n, we're going to use when n equals 7. 1, 2, 3, 4, 5, 6, 7. Yeah. So when n equals 7, so a sub 7 is 0.05. Oh man. Hold on, let me try this again. 0.05. It doesn't like this software doesn't like my touchscreen at all. 0.05 equals a sub 1, which is -6, plus n minus 1. And because we are doing n equals, I say 7? 5, 6, yep, n equals 7. That's going to be 7 minus 1. Oh my gosh. And then times the common difference. So we have all these numbers here. So we would calculate your common difference. 7 minus 1 becomes 6. We would subtract 6 both sides. So 0.05 minus 6 is what?
Don't you add 6 since it's a -6?
Yeah, I was testing you guys. That's a -6. We add 6 to both sides. One person's paying attention. All right, so we got 6.05 equals 6D. And then we do what? Divide by 6, yep. Divide both sides by 6. What the heck? All right, someone type 6.05 divided by 6 and tell me what you get. Give me a fraction. Like, you can give me decimal if it's a nice decimal. Does it repeat? Does that 1.0083 repeat? Okay. If it repeats, you never want to round your work. You always want to keep it exact until your final answer. So we have to have it as a fraction. So 121 over 20. All right, so we now have the common difference. Now what do we do? We just add it. We do. So what we would do is -6 plus 121 over 120, hit enter, write that number down, adds 121 over 120 again, write that number down, and so forth. So I'm going to skip that step just to save time. But remember, your common difference is 121 over 120, so you just keep adding that and write down that number. That's all you got to do. Yeah, there's no point of plugging it into the formula because you're just gonna, it just takes longer to get the same thing. And if we know an arithmetic sequence is a sequence where you have a common difference where you're adding that same value over and over again, you just start at the beginning, -6 plus the common difference, plus the common difference, and so forth. And then eventually you get up to, you'll get 0.05. The values are ugly, you're right. That was my fault for making a bad example. On your test, your quizzes, it won't be ugly. It'll be nice. Promise. Okay, so it is 17 after. So today's lesson, this is day 2. We're doing geometric sequence and series. So goal, we're going to write the equation for a geometric sequence, and we're going to calculate the geometric series, the sum, that is. All right, we're being recorded. All right, make sure you have your paper, pencil, pen, calculator. Okay. And a geometric sequence is one where the ratio between consecutive terms is constant, known as the common ratio. Now, the common ratio, that variable is an italicized R. So you'll see that going through the Learn modules and through my examples. So for example, 1, 2, 4, 8, 16. Now, if you notice, going from 1 to 2, you're adding 1, right? But then 2 plus 1 isn't 4. So it looks like you're adding 1, then you're adding 3, then you're adding 7. So that right there tells us it is not arithmetic. It tells us it's either geometric or something else. So to determine if this is geometric, what do? We find that common ratio. Yeah, the second by the first. Yep, you just take the second divided by the first. So what's 2 divided by 1? 2. Yeah, what's 4 divided by 2? 2 again, weird. What's 8 divided by 4? Weird, it's also 2. And then what's 16 divided by 8? 2 again, crazy. So you have to check at least 3 numbers to make sure that it's always the same. In this case, it's always 2. So I just showed that on the screen. Hopefully you can see that now. It's always 2, so that means the common ratio is 2. And just this is kind of like nice to know. The terms in between non-consecutives are called geometric means. This definition is going to play a part in some of the examples on your assignment, on your quiz, on your test. They might say find your geometric means. And this is something fun. This is not in your Learn modules, but mathematically, if you wanted to find like 2 and you only have 1 and 4, it's a square root of 1 times 4. That gives you 2. This number right here, or number 4, is a square root of the products of 2 and 8. 2 times 8 is 16. The square root of 16 gives you 4. This number right here is the square root of the products that are surrounding it. So that's just, it's nice to know, fun to know. You actually won't ever use this equation or this formula, if you want to call it that, on your quizzes or your test. I just thought it was kind of neat to show you. All right, now to the good stuff, the actual formula. So to calculate the nth term of a geometric sequence is given by a sub n equals a sub 1 times your ratio raised to the n minus 1 power. If your ratio is negative, you want to keep it in parentheses. That's important for when you actually type this stuff in. Like yesterday, a sub 1 is the first term. A sub n is the term we're trying to calculate, or maybe that's given. N is the location that we're trying to find, and then R is, of course, the common ratio. And hard yet. All right, so we want to find the formula. So here we're not calculating anything, we're just plugging stuff into the formula just to set it up. All right, class, what is the first term in this first sequence? It is, in fact, 4. What is the common ratio? It is 5, and we got 5 by taking 20 dividing by 4 gives you 5. 100 divided by 20 is 5. 500 divided by 100 is 5. So you want to get the ratio, and then you have your ratio, and we have the first term, so we just plug it in. So that's setting it up to find an nth term. So everyone quickly do number 2 and 3. And then I'll take 2 volunteers to go ahead and write it for us below 2 and 3. Right axis. Let me see. Right, I do. All right, volunteer. Just go ahead and raise your hand if you'd like to do number 2. All right, Emily, go for it. Number 2. Volunteer for number 3. All right, is it Meha? Is that how you Miha? I don't know how to pronounce that.
It's Maija. I don't know if you can hear me, but
And Maija, I was totally off.
it's okay.
All right, thank you. Maija. All right, Maija, number 3. And you don't have to show the work of doing all those consecutive. Like all the ones I'm giving you today, they are geometric sequences. I'm not going to trick you on those. See, so Emily, you feel my pain. So yeah, it's not that good. The writing on this program is not good.
If you guys need my help with typing or writing, just let me know.
Yeah, they need to improve that. It drives me nuts.
You should be able to give recommendations to them. I know certain teachers are.
I don't know. Nah, I'm good. I'll just wait for the update. Good, perfect. They both look really good. So one thing I want to point out is whenever you have a fraction like we do in this case, you must put it in parentheses, because if you don't, and you put 1/2 to the n minus 1 power, or whatever power it may be, without the parentheses, you're only telling us to power the numerator and not both. And same thing goes for this -2. If you don't have the parentheses around the -2 and you type it in, your calculator will think that you want to do 2 raised to the power and not -2, and there is a big difference. So I went ahead and typed these answers. So I got. Dun, dun, dun.
It is positive half because
It-
if you do negative half, it's going to become a positive. That's why I was trying to ask you. That's why I said question in chat.
Ooh. So, looks like your ratio, I don't see the work for it. So this was, so you have to do the 1/5 divided by the negative 2/5. So, and you can type it in as long as you put parentheses 1/5 divided by parentheses negative 2/5, hit enter, keep it as fraction form. So whenever you divide a fraction divided by a fraction, we learned way back when, I don't know what grade we did this, but you flip and multiply. So it's 1/5 times the reciprocal. So that's why it's 1/5 times negative 5/2. And then that reduces to negative 1/2. So everything else is right except the ratio, small mistake. And there's the clean work for that one. So nice job, everyone. Ah, 2/5 by 1/5. That's that's good. You make the mistake now. So on your quiz and your test where it actually counts, you won't make the mistake. So it's always the second divided by the first. And just like arithmetic, it's the second minus the first. That's consistent. Okay, so we have these three examples. So we want to find the 8th term for all of these. So let's go ahead and find the common ratio. Now, some of these, you can probably look at them and figure out what the common ratio is. So looking at 4 to 8/3 to 16/9, let's look at 4 as 4 over 1. So going from 4, 8, 16, 32, what are we doing? The numerator, what are we doing? 4, 8, 16, 32. Multiplying by 2, yes. And then what about the denominator going from 1, 3, 9, 27? What are we doing? Multiplying by 3. You put it all together, you multiply the previous term by 2 over 3. 4 times 2/3 is 8/3. 8/3 times 2/3 is 16/9. 16/9 times 2/3 is 32 over 27, and so forth. Yeah, magic. Yeah. So that can save you maybe a step, right? If you can recognize those easy sequences, those geometric, those easy ones, you can just kind of do it like that. But mathematically, 8/3 divided by 4, we take the bottom 4 over 1, we flip and multiply. So 8/3 times 1/4, and that's how we get 2/3. So that works too, right? I will leave it up to you to decide how you want to approach to calculate the common ratio. Going back to this first one here, 4 to 20. So 4 times 5 is 20. 20 times 5 is 100. So we probably could have figured that out without actually doing the math. Negative 12 to negative 6, we're multiplying by, so you got to be careful because it's always multiplying by something, not dividing. So yes, negative 12 divided by 2 is negative 6. But multiplication wise is multiplying it by 1/2. So be careful of doing that shortcut when it comes to division, because the common ratio is what you're multiplying by. Okay, so we have the common ratio. Now let's go ahead and set this up. So there is the formula with stuff plugged in. And we're going to find the 8th term. So wherever you have 8, or sorry, wherever you have n, you replace it with an 8. I want everyone to go ahead and calculate what the 8th term is. And don't type it yet. I'm going to, I'll do a timer on my phone. Let's do 1 minute. So you got 1 minute to calculate that, and then if you finish in that 1 minute, go ahead and start numbers 5 and 6. You want fractions. Yep. So kind of like a rule of thumb is if your original problem has fractions, you want to stay in fractions. If the original problem has decimals, it is okay to have your final answer in decimals. That's generally a good rule to follow. Oh yeah, so there's not 4 colors. You can do more colors. Oh, it's been a minute. Go ahead and type in chat what the answer is. 512 over 2187. Why is my box messed up? Antonio, are your boxes covering stuff properly?
On my end, yeah, they are.
Okay, mine they're not. But whatever, it's fine. Right, 512 over 187. So you guys can't see the answers for the next 2 questions? Okay, I can. I don't know why. Hopefully when I'm moving the boxes to cover them on my screen. Is it still covered on yours?
Yeah, they're still covered.
All right. Oh, I don't know. New row. Fun. All right. Number 5. Number 5. I'm going to give you guys another minute for number 5. So do the work on your paper, and we'll type in the answer. We're making good time. Hey guys, am I overly bright on my webcam? Is that better?
Yeah, before you look kind of like a supermodel who had the lighting on her and like the wind blowing in her hair.
Yeah. Okay. I have a backlight. Obviously, I just turned it off. Oh, that's a fast minute. Okay, go ahead and write the answer. Negative 384 is correct. Antonio, I can't click that box. Can you click it?
Yeah, I got you. Let me take it out. Delete it.
Yeah.
Gone.
Stuff keeps moving around on my screen. I don't get it. Okay, we'll do another minute for number 6. And does anybody want to see the work for number 5? Right. So as you get to number 6, I will quickly work out number 5 on the board. That is a 3. That's a solid 3.
Thank you. Only if I didn't have it so thick, but
Eh. So we're doing a sub 8. Equals. Common ratio is -2. And then we're doing 8 minus 1 is 7. I'll go ahead and write it just for completeness. And that becomes 7. So you would type that in 3 times parentheses, -2 in parentheses to the 7th power, and you hit enter, and then that's how you get this right here. Okay, what's the answer for number 6? The 5 over 384. That sounds good. Is good. All right, -5. Now, if you notice, so I personally like having the negative in the numerator always. That's just my preference. When you guys do your quizzes and tests, and it's auto-graded, right, on those, it likes your negative out in front. So that's where I'm putting it, just because that's how you have to type it in to get credit. Because if you put the negative on top, it's not smart enough to give you credit. I don't know why. All right. What's the common ratio for number 6? Common ratio is 1/2. Very good. All right, we good to go on? Anybody want to see this worked out, or are we good? I can always come back at the end if you want. We good. Okay. Okay, so reverse engineering the geometrics formula. So given 2 terms in a geometric sequence, find the term named in the problem. So number 7, a sub 3 equals -32, and a sub 4 equals 128. We want to find a sub 9. So this is going to be similar to how we did it in the arithmetic. We are going to set it up for finding, well, in this case, we can find the common ratio because we have 2 consecutive numbers. When that happens and it tells you it's geometric, we can always do the second divided by the first. But you can only do this if you have 2 consecutive terms. In this case, we do. In number 8, we don't. A sub 2 and a sub 5. So in this case, we do 128 divided by -32, and the common ratio is -4. That's helpful. Next, we don't have a sub 1 yet, so we probably have to find that. To do that, we're going to use one of our givens here, either a sub 3 or a sub 4. I think I used when n equals 3. N equals 3, we just plug that stuff in. A sub 3 is -32 equals the a sub 1, which we don't know, times your common ratio, which is -4 raised to the n minus 1. And n in this case is 3. 3 minus 1 gives us 2. Let me write some stuff down here. So this becomes 2. And then -4 in parentheses raised to the second power is 16. So we have 16 times a sub 1 equals -32. We then divide both sides by 16. And voila, we have a sub 1. So now we have a sub 1, and we have the common ratio. That's all we need, right? we just plug that stuff into the formula. Yep, go ahead.
Couldn't we have just divided by -4 the whole way through?
So remember, common ratio is not dividing. Common ratio, once you have that, you multiply the previous term. So we can do -32 times -4. You get a number. That number times -4, your next number. That times -4, your next number. So you got to be careful. Now, going backwards, we can do -32 divided by -4. That's a sub 2. So -32 divided by -4 gives us positive 16. And then that's a sub 2 going back one more to a sub 1. Positive 16 divided by -4 gives us a negative 2. Right? 32. Oh, my math is bad. -32 divided by -4 is positive 8. Positive 8 divided by -4 is -2. You understand what I'm trying to say. But Antonio, to answer your question, yes, going backwards, multiplying going forward. What if on your quiz or your test, I give you the 52nd term and like the 59th term? Are you going to want to divide 50 something times to get to a sub 1? I would hope not. All right, so we have all the stuff we need. We just plug that stuff in. What's up? I teach with my my dog in my lap, guys. Here she is. I think she wants to get down. All right, so we just plug stuff in, we do the maths, and someone type that in to make sure I did it right. I probably did. Yeah, big number. All right, looks good to me. All right, number 8. A sub 2 equals 8 and a sub 5 equals 512. Now, sure, we could try to guess. So you have a sub 2, a sub 3 blank, a sub 4 blank, and a sub 5 is 512. We can I guess guess and check, like maybe it's times by 8 every single time. Maybe it's times by 10 every single time. I don't know. That's one way to approach it, not the best way. So the best way, the mathematical way, we are going to use a sub 2 and a sub 5. Generally speaking, it's easier to use your smaller one first. So between a sub 2 and a sub 5, well, 2 is smaller than 5, so you want to use the a sub 2 stuff. So we want to say n equals 2, and we want to plug that stuff into our formula. So when n equals 2, a sub 2 equals 8 equals a sub 1, which we're trying to find, along with r. So times r raised to the 2 minus 1 power. So the problem here is, in this equation, we have a single equation, and we still have 2 unknowns. And we all know that you can't solve definitively, and that happens. So we're going to have 2 variables. Now, remember, our goal is to solve for a sub 1. So what we're going to do, first I'm going to get my pen out. We're going to simplify this. 2 minus 1 is 1, and then r to the first power is just r. So we have 8 equals a sub 1 times r. We're then going to divide both sides by r. And that's how you get a sub 1 equals 8 divided by r. When I show it to you, it'll make more sense. So all I did was I divided both sides by r. Okay, so we're getting a little closer. Next, we're going to use the other given, in this case, our a sub 5. So when n equals 5, we just plug that stuff in. But one thing different, where you see your a sub 1 here for this, we'll call it part 2 of this problem, this a sub 1, you're going to replace it with what it equals, which is 8 divided by r. So your a sub 1 becomes what we solved for in the first step. And we got 8 divided by r. Is everyone on the same page? All right, we got some yeses. We're doing good. Once we do that, we can simplify. So 5 minus 1 is 4. So we have 8 over r times r to the 4th power. Well, that r on the bottom and the r to the 4th on top can reduce. Move my little box down a little bit. So that r on the bottom goes away. The r to the 4th on top becomes what? R to the 3rd power. R to the 3rd power. Now, off to the side, let me show you what happens. So that's 8 over r times r to the 4th. Oh my gosh, I'm drawing Emily 4s. R to the 4th. And we can put this over 1 if it makes you feel better about it. You don't have to. I don't like doing that. So that's r to the 1st on the bottom, right? So when we simplify this, one of these, so this cancels out, and then one of these cancels out. So that becomes a 3. Oh my gosh. Does that help seeing it that way? Why? Because those are called exponent rules. Yeah, those are the exponent rules. All right, so we'll talk later, and at the very end, hang on, and we'll kind of go through some of the exponent rules. I still see boxes, but they're under. Let me just remove everything. That way, stuff's not covered. Oh, my dog's back. She wants to sit back in my lap. Just give me a second, guys. Come on. Good girl. She sits at the edge of my chair, and she oinks at me. Yeah, I don't know. I don't know either. Yeah, she oinks at me. She wants me to let her on my lap. I don't know. Okay. Finishing up this problem. So we then have 512 equals 8 times r cubed. We then divide both sides by 8. That's how we get 64 equals r cubed. We then do the cube root of both sides, and the cube root of 64 gives us 4. The cube root of r cubed obviously becomes r, and we now have the common ratio. Okay, so once we have a common ratio, we're going to use so we now have a sub 1. We now have the common ratio. It's all we need. We just use the original formula. We plug those two things in, and we're trying to find the 10th term. So n equals 10. So I have a sub 10 equals a sub 1, which is 2. Oh, by the way, we found a sub 1. So let me draw some lines here. So we can plug in what r is into this step here. A sub 1 equals 8 divided by r. We now know what r is. So a sub 1 equals 8 divided by 4. And 8 divided by 4 gives us 2. That's why I have a 2 right there. So we have a sub 1 is 2 times your common ratio of 4 raised to the 10 minus 1 power. 10 minus 1 is 9. So I would type in 2 times 4 to the 9th power. I hit enter. You should all get 524,288. Is that not what you guys got? N is 2 in this step, in this first step here. Then n is 5 because of this in this second step. And then ultimately, this problem says find a sub 10. So that's why n is 10 in our third phase, or third step. So you're talking about this 2 here? So this 2 is from the formula, a sub 1. And we know a sub 1 is 2 because we have r. We plug r equals 4 into here, and 8 divided by 4 is 2. And that's how we know a sub 1 is 2. Okay, let's do another example, and maybe it'll catch on. It's okay if you don't understand the first time. Do another one. Okay. All right. All right. We're given 2 terms, a sub 5 and a sub 2. Our goal is to find a sub 9. So our first step. Now, if you notice, I have them switched. I have a sub 2 listed second, and I have a sub 5 listed first. Generally speaking, you want to use the term that appears first in the givens for your phase 1. It's generally easier. You don't have to. It's just easier usually. All right, so when n equals 2, and n equals 2 because, well, that's the given. A sub 2 equals -8. So n equals 2. We plug this into the actual formula here, right? So a sub 2 equals -8. We don't know a sub 1. We don't know the common ratio, but we know that n equals 2. So that's what we plug in. Sarah, are we good on this first step? All right, so 2 minus 1 is just 1 for that exponent. And then I didn't write that steps, but off to the side, I'll just go ahead and show the step I'm doing. So we have -8 equals a sub 1 times r to the first power, because 2 minus 1 gives us 1, right? So I am switching colors, and I'm going to divide both sides by r. So this cancels out. And that's how we get a sub 1 equals -8 divided by r. All right, we good so far, Sarah? All right. All right, phase 2. We are going to use the other given. We'll use a sub 5. So n equals 5 in this case. So we're going to plug in the stuff. So n equals 5 because of this 5 here. A sub 5, so we're using this formula again, right? A sub 5 equals -64. That goes here. Equals a sub 1 times r raised stuff. Well, a sub 1 we found in the previous step. A sub 1 is -8 over r. So instead of using a sub 1 right here, we replace what it equals. It equals -8 divided by r. We good on that, Sarah? All right. And then times the common ratio raised to the n minus 1 power. So r raised to the n, well, n is 5 in this case. 5 minus 1 gives us 4. So off to the side, I'm going to go ahead and show the maths that I did. Is that even a word, maths? Is the word maths even a verb? It should be if it's not. Negative, oh my gosh, Emily's 4 again. It haunts me every day. -64 equals, we have -8. -8 divided by r times r to the 4th power. Oh my gosh, it's there again. It never stops. Never. I'm never going to live it down either. All right. So let's go ahead and use different color. Remember this 5 minus 1 is, that's a 4, guys. That's a 4. Oh my goodness. So there's a 1. Yeah, Antonio tried to do a 4 and he realized he messed up too and he erased it. I saw that. -8 divided by r to the first times r to the 4th. Well, one of these cancels out and one of these cancels out. So that's how we get -8 times r to the 3rd power in this next step. Now, if any of you are confused on that step on how we simplified exponents, email me or message me on Skype, and I will send you I'll find you a nice YouTube video of someone explaining exponent rules and simplifying those. So this is something that you should all know or remember vaguely, and if you're kind of rusty, you need to look back at. You probably don't have past notes unless you're well organized, or you check online. Yeah, but past notes, are they labeled and organized and easy to find? So if not, just message me on Skype and I will send you a nice video that explains it. All right, next we divide both sides by -8. That's how we get 8 equals r cubed. We then do the cube root both sides, and the cube root of 8 gives us 2. So we now have r equals 2. So we have the common ratio. We will have the first term. So to find the first term, we're going to take what r equals, and we are going to plug that into r to find a sub 1. So -8 divided by 2 gives us -4. And that is your a sub 1. So we have the ninth term. So a sub 9 equals -4 times 2 raised to the 9 minus 1. 9 minus 1 is 8. So type in -4 times 2 to the 8th power, hit enter, you get -1024. Right. So if this step is the hardest to understand, simplifying the exponents, that's okay. That's not bad. If you understand everything that we did here, except maybe this part here, you're doing okay. We can fix that after class today. Ours shows there. All right, guys, we have just 3 pages left. This page and then 2 more pages. We're almost done. I know I went over time again. Doesn't sound like me at all. But summation. So we have a summation of a finite geometric series. So with geometric series, there's an equation for a finite series, and there's also a formula for an infinite series. And we're doing infinite series tomorrow. So for a finite series, meaning I have a finite series is a list of numbers that have an end. So I may tell you that here's a geometric series, and it only consists of 5 numbers. That would be a finite series. Now, if I give you a series that went on forever, that'd be called an infinite series. Kind of makes sense. So yeah, everything else is the same here. We have your a sub 1 is your first term, r is your common ratio, n is, in this case, n is the so this is a typo. This is not the location. This is the number of terms in the sequence. So if you're writing this down, make sure you fix that. I will send you a link to download this PowerPoint after we're done. But this has to be changed. This is n is the number of elements in the sequence. Sorry about that. All right, so I have 3 examples left. Yep, we'll only do these 2 since I don't have this one typed out, and then we'll call it. And maybe I'll have this one as bell work tomorrow. I think that'll be good, right? We'll do this one for bell work tomorrow, and then we'll finish these 2 up. Okay, this is pretty easy. This is probably the easiest part of the lesson. Nothing tricky about it. I give you I tell you, evaluate the geometric series described. So in this series, it goes -2, 12, -72, +4, 32, and so forth. And then n equals 7. So this is 7 elements. So we have to add up all these elements, the first 7. This is being recorded, yes. All right, so to find the common ratio, what do we do? What do we do? What do we do? Find the common ratio. We divide. Yeah, divide what by what? All right. Aisha, nice job. 12 divided by -2. You learned your lesson. I like it. All right, 12 divided by -2 is -6. So we can easily see that -2 times -6 is 12. 12 times -6 is -72, and so forth. All right, so we have the common ratio, we have our first term, and we have the number of elements in our series. So we just plug that stuff in. All right, simplify what you can. So I would simplify probably the denominator, and that's really about it. I would do 1 minus -6, which we know is 7. And I would just type that in. So go ahead, everyone, on your calculator. This is the hardest part, is typing it in. Don't forget your parentheses. If you have a FX115 ES or an FX, what is that other one I have? Oh, here it is. Whatever that one says, FX300, I think, which is almost the same one. It makes it easy to type it in. And tell me the answer you guys get. Negative 79,982. Let's see if that sounds right. Yep, that sounds right. Nice job. If you did not get that answer, you didn't type it in right. See, and Emily used the FX115 and she loves it. I'm speaking for her, of course, but I'm guessing she loves that calculator. Yes. The best $15 she spent in math class ever. So yeah, she's never spent money in math class before. So that's a true statement. Best $15 ever. All right, number 11, everyone. Let's calculate the common ratio. Now, looking at this, can you probably figure out what the common ratio is without actually doing any math on paper? Could you do this in your head? Find the common ratio? Yeah, we can see the numerator doesn't change. It stays 5, 5, 5, 5, so forth. But the bottom part, the denominator, does change. It looks like, so that's 5 over 1. 1 times 3 is 3. 3 times 3 is 9. 9 times 3 is 27. So the common ratio is 1/3. That is super easy to see on this problem. On your quiz, on your test, it may not be that easy. So to do the maths, we do 5/3 divided by 5. We flip and multiply, and that's how we get 1/3. So we have a sub 1, we have the common ratio. We plug those two things in to get this. I like doing the denominator. So 1 minus 1/3 is 2/3. Yep, 2/3. Yep. And we just type that in. So everyone, type that in. Araceli, yes, that is a problem. So when you switch from full screen to non-full screen, for like 10 seconds, those boxes shift. And if you wait long enough, they should cover up everything again. Yeah, Neuro has a ways to go to fix their stuff. So Neuro, if you're watching this video, you got a little bit of work to do. So everyone type that in. So this is I want to say this is the most important step right here is typing this in. Because your work can be beautiful on your paper, but if you can't type this in, you get 0 points. Savannah, that might be right. That sounds like a good answer to me. Wait, actually, it doesn't sound like a good answer because I don't have a whole lot of space. Savannah, does that become a... So convert that to decimal, because mine actually wouldn't keep it in fraction form. Ooh, 7.4. You must be using a TI-84, Caitlin, is that right? Or a TI Inspire is my guess. Oh, Desmos. Yes, Desmos has more memory. So yes. So the answer, let me write this down. So if you're using Desmos, you do get a fraction. Let me write it down. 16,400. There's that 4 again. 16,400 divided by 2187. So mine wouldn't actually give me a fraction. On your quiz, on your test, you won't run into that problem. Just so you know. Yeah, so if your calculator doesn't give you a fraction form, it's okay for decimal. That's why I had decimal here, because I didn't use my graphing calculator. I used the Casio, and I guess the numbers were just too big to crunch for the Casio. That's okay. So you probably want to keep your answers in fraction form on your quiz and your test, unless the question you're working on started with decimals. So follow that rule. It'd be like 16 yo. Exactly. Yes, I was thinking the same thing when I saw that. All right, everyone. We'll stop here, and of course, I hope you learned something. And I will see you tomorrow for day 3 of whatever we're doing right now. Geometrics series. We're doing infinite ones tomorrow.